You built an AI agent, you tested it manually, and it looked great. You shipped it. And then a client started complaining. The agent gave wrong answers. It broke things it had fixed before. It repeated the same mistake 3 weeks in a row. And you had no idea why. If the sound is familiar, here is what most people don't understand. The problem wasn't the AI model itself. The problem was no system to measure whether it was actually working or not. That is what today's video is about, an agent evaluation. The discipline that separates teams that ship confidently from the teams that are always fighting fires. At the end of this video, you will understand exactly why this matters, and you will have a clear practical framework to start applying that right now. Let's get into it. Let's talk about something important before you can build a good evaluation. You need to understand what one actually is. At its simplest, an evaluation is give the AI input, it produces an output, and you apply grading logic to measure how well it did. That is the whole idea. A single-turn evaluation are the most straightforward version. One prompt, one response, check the answer, and this is how most early LLM were tested, and simple but limited. Now, this is where things become interesting. As AI agents got more capable, a single-turn evaluation stopped being enough. A real agent doesn't just respond to one prompt. It takes a series of actions across many turns using tools, updating its environment, and adapting its goals. That gives us a multi-turn evaluation. Imagine coding agent given a task, building an MCP server. It looks through tool calls, through intermediate steps, updates the environment with actual implementation, then grading that. You run unit tests to check whether the working MCP server was actually produced or not. So that is multi-turn agent evaluation. There are key definitions in evaluation, like tasks. Tasks is a single test with defined input and a success criteria. Then there is trial. A trial is like one attempt at a task, run multiple trials, model output vary between runs. And there is a grader, is what a score that agent performs. Think of it as an examiner. There is a transcript, it is called sometimes trajectory. It's a complex history of what happened, every tool call, every response, every decision. The outcome is the final result, not what the agent has said happened, what actually happened. Let me be clear about this. If an agent says it booked the flight, that doesn't matter. The real question is, did the flight actually get booked or not? That is the outcome. Then we have the evaluation harness and agent harness here. These are the systems that run the evaluation and run the agent, and finally the evaluation suite, which is simply a collection of tests designed to measure a capability. Okay, so now let's see why we need even evaluation. Most of people doing this wrong. They build, they ship, they wait for the users to complain, then fix it. That is a reactive group, and it is exhausting, really. Here is the real problem. The breaking point always comes in the same one. User report the agent feels was after recent change. The team is flying blind. No way to verify, except to guess and check manually. They can't distinguish a regression from the noise. Without eval, debugging is purely reactive. Wait for compliance, reproduce manually, fix the bug, hope nothing else regressed. Repeat forever. If you are building a business, pay attention to this. There are direct competitive advantage here. When a more powerful model drops, which is happening consistently, teams without eval faces a week of testing. Teams with evals run their suite in a day. Can their prompt upgrade faster than competitors? People underestimate this. Evals also force you to define what success actually means for the AI agent. Two engineers reading the same specific might come with a different interpretations for how the edge case should be handled. In eval suite, resolves that ambiguity. In writing the test case before a single line of agent code is committed. And let's see methodologies and different frameworks. AI evolution usually happens into spaces: pre-production and production. Pre-production means before users sees anything. This is where teams run evaluation suites and catch failure early. Then comes production evaluation, monitoring real user behavior, tracking failures, measuring outcomes, and there is another approach that is becoming extremely popular, is LLM-as-a-Judge. Instead of humans usually reviewing thousands of outputs, another AI model creates the result using a predefined rubric. So people underestimate this because when done correctly, it allows them to scale evaluation dramatically and very fast. Now let us see the types of graders for AI agents. There are three types of major graders, like code-based graders, model-based graders, and human graders. Each one has different purpose, and the best evaluation system combines all three. Like model-based graders adjust with the AI models to evaluate AI output. For example, was the answer helpful? Did the agent follow the instruction? Was the reasoning sound? Here is what most people don't understand. Many important qualities can't be measured using code alone. Things like clarity, helpfulness, and communication quality. That is where model-based grading becomes powerful. The biggest advantage is it is flexible and it handles open-ended tasks extremely well. But it has also a downside. It is not perfectly deterministic, and it usually needs a collaboration against a human judgment. On the other side, there is code-based graders. These are objective, fast, cheap, and reproducible. For example, is the test pass? Did the code complain? Did the agent call the correct method? Did it create the expected outcome? And this can completely change how you work if you are building a coding agent. Because code-based graders remove opinions from the process. The challenge is that it is something to be reached. Means it is not flexible like model-based graders. A valid solution might fail simply because it doesn't match the expected pattern. So while coding graders are excellent for correctness, they don't always capture quality. And let's see a human graders finally. This is still a gold standard. Subjective matter expert, reviewers, human evaluators are there. Those people can identify a subtle issues that automated systems miss. But there is a trade-off also. Humans are expensive and humans are slow. And humans don't scale easily. That's why most modern evaluation systems uses human grading to calibrate model-based grading early. Step 1 is use tasks you already testing manually. Step 2 is write tasks with a clear success or criteria. Step 3 is build balanced problem sets. And 4 it is build a robust eval harness with a stable environment. And the fourth step is design an eval harness, and graders like build a robust eval harness with stable environment. It is essential that agents in evaluation function roughly the same as the agent used in production, and that the environment itself doesn't introduce a further noise. Each trial should be isolated by starting from a clean environment. Unnecessarily, a shared state between runs like leftover files, cached data, Resource executions can cause a corrected error due to infrastructure flakiness rather than agent performance. A shared state can also artificially influence performance. For example, in some internal evals, we observe gaining unfair advantage on some tasks by examining the history from the previous year. And step 5 is designing graders through thoughtfully. We have seen that the graders, different types of graders, so we have to design at step 5. As we have discussed the graders pattern, a grade eval design involves choosing the best graders for the agents and the tasks. So it should be recommended like choosing the deterministic graders where the possible LLM graders were necessary, or the additionally flexibility, and using human graders for additional validation. And step 6, like check the transcripts, as we have seen that what transcript is. And step 7 is monitor for capability eval saturation. An eval at 100% trackers regression but provide no signal for the improvement. Eval saturations occur when an agent passes all of soluble tasks, leaving no room for improvement. For instance, like a benchmark like verified score starting at 30% this year, and 14-year models are now nearing saturation at greater than 80%. And finally, the step 8, keep evaluation suites healthy long-term enough through contribution and maintenance. At the conclusion, let's bring everything together. And agents are becoming more powerful every month, every day, but every time we can say, right? The power without measurement creates choice. The power with measurement, it creates real agents. Here is the real problem. Many teams focus entirely on building agents. Very few focus on evaluating them. And that is often the difference between great demo and great product. If you understand evaluation, you are already ahead of many people, because evaluation is what transforms an agent from something interesting into something reliable. And in the future, reliability will matter far more than flashy demos. If you found this video helpful, comment agent events below. And if you want a deeper breakdown of evaluation frameworks used by leading AI companies, let me know, and I will make a full video follow up about this. Please make sure that you just subscribe for next, and thank you very much. See you.